Okay, let's do the second part of section 3.2. We're using algebraic methods to solve linear systems. It's called using algebraic methods because we just finished using substitution, now we're using elimination, we're using algebra to solve linear systems to find our ordered pair, x, y. So now we are working on elimination. You get rid of one of the variables by adding or subtracting the equations. You may have to multiply one or both equations by a number to create variable terms that can be eliminated. That sounds really crazy, but it'll make sense on the next slide. So if you remember the definition from the previous slide, we want to get rid of one of the variables or eliminate it by adding or subtracting the equations. So if you look right here, we have a positive 2y and a negative 2y. If we add these equations together, okay, straight down, just like you collect like terms, we have 3x plus 4x. That gives us 7x. 2y minus 2y, they're gone, and then 4 plus a negative 18 is a negative 14. Divide both sides by 7, and we have x equals negative 2. Now once you have one of your variables, you can plug that into the equation, either equation, you pick, doesn't matter. Plug it in for x and solve for y. Negative 6 plus 2y equals 4 plus 6. Awesome handwriting there. 2y equals 10. Y equals 5. Our answer is negative 2, 5. And again, you would take this ordered pair and plug it into both of your original equations to check your work. Let's try another one. So I have two equations here. Notice neither coefficients matches with an opposite sign. Our goal is to have the same coefficient and opposite sign. I have a 3x and a 2x, not the same, not opposite signs. 5y and 3y, not the same. So what we do is we multiply your first equation and multiply your second equation by coefficients, because our goal is to get the same coefficient, opposite sign. So if I multiply this entire first equation by a 2, and this entire second equation by a negative 3, and I got that just by taking this number and putting it up there, taking this number and putting it down there. I switched them, and that works every time. Now once we multiply, 2 times 3 is 6x, 2 times 5 is 10y, 2 times negative 16 is 32. Okay, negative 3 times 2 is negative 6. Negative 3 times 3 is, negative 9. Negative 3 times negative 9 is positive 27. Now I have x's with the same coefficient, opposite sign. So if I add these together, the x's are going to cancel. 6x minus 6x is gone. 10y minus 9y is 1y. 32 minus 27 is negative 5. So let's plug that into either equation. It doesn't matter which one. 3x plus 5 times negative 5 equals negative 16. 3x minus 25 equals negative 16. X equals 9, x equals 3. Our answer is 3, negative 5. All right, you try to use elimination to solve the systems of equations. If you look, you already have two variables that have the same coefficient and opposite signs, so push pause. Here you go. Yes, you got a fraction for your first variable, but notice when you plug it in, the 4's cancel out and your math is easy again. Don't forget to check your answers by plugging these into both equations when you're in a quiz or a test. Alright, word problems. Okay, I saved all the word problems for the substitution and elimination section. I didn't want you guys to have to graph these, so we're going to work through word problems doing the algebraic methods. Now, we have systems of linear equations. That means we need two equations with two variables. So if you keep that in mind when you read all of your word problems, it might help you. So let's read this one. A veterinarian needs 60 pounds of dog food that is 15% protein. He will combine a beef mix that is 18% protein with a bacon mix that has 9% protein. Now, that should be how many pounds of each does he need to make the 15% protein mixture? Now we need two variables. Okay, every problem you need two variables. So we're going to say X is the amount of beef mix in the mixture. Y is going to be the amount of bacon mix in the mixture. Okay, now let's try to come up with two equations. We're going to do the amount of beef mix plus the amount of bacon mix. And how many pounds does that have to equal? So if you mix in so much bacon and so much beef, we need that to be 60 pounds of dog food, right? Now, our solution has to be 15% protein. So 15% of that 60 has to be protein. X is beef. So what's our percentage of beef? 18x. Our percentage of bacon? 9y. So I have two equations, two unknowns. This is my system of equations. Now to solve this system, you can use substitution or elimination. Since your x and your y don't have coefficients, I'm actually going to use substitution. So I'm going to start a new page. Oops. X plus y equals 60, and 0.18x plus 0.09y equals 0.1560, which if you get 0.15 times 60, your answer is 9. So y equals 60 minus x. I'm going to plug this in for y. Keep doing the math. 0.18x plus 0.09 times 60 is 5.4 minus 0.09x equals 9. Collect like terms. We have 0.18 minus 0.09, which is 0.09x, plus 5.4 equals 9. 0.09x equals 3.6. X equals 40. So I need 40 pounds of beef. X equals 40. Goes back into one of the two equations. I'd pick the easiest one. Replace or substitute. Y equals 20, which is your bacon. So we need 40 pounds of beef and 20 pounds of bacon to make our dog food. Another example, a coffee blend contains Sumatra beans, which cost $5 a pound, and Kona beans, which cost $13 a pound. If the blend costs $10 a pound, how much of each type of beans, each type of coffee is in the 50 pound of the blend? So again, we need X equals a bean and Y equals a bean. So X plus Y equals 50 pounds. Okay, $5 for Sumatra plus $13 for Kona equals $10 total. Sorry, that'd be $10 times your 50 pounds. So how much pounds? X. Pounds Y. So $5 per pound, $13 per pound, $10 per 50 pounds. Make sense? Now we're just going to go ahead and solve. I'm going to rewrite it on the next page. I'm going to go ahead and solve this with elimination to practice that a little more. I'm going to take this top equation and multiply it by a -5. And then I can eliminate. So I get negative 5x minus 5y equals negative 250. Rewrite the second equation and add them together. Negative 5x plus 5x, negative 5y plus 13y, and negative 250 plus 500. Divide by 8. That gives us y equals 250 divided by 8, 3125. You take that, plug it back into an original equation. X plus 3125 equals 50. X equals 50 minus 3125, 1975. Sorry, I just checked my math. That would be 1875. Okay, you try it on the next one. You try. The Miller and Benson families went to a theme park. The Millers bought 6 adult and 15 children tickets for $423. The Bensons bought 5 adult and 9 children tickets for $293. Find the cost of each ticket. 2 equations, 2 unknowns. Try to write them and solve. Alright, I've solved y on this page. I used elimination to solve. And next page shows x. Come in with some questions tomorrow. Good job, guys.